Today in Algebra 2, we are going to look at solving linear inequalities. Let's quickly review what an inequality is. It is going to have an inequality symbol that is less than or equal to, or greater than or equal to. Okay, so a linear inequality is only going to have one variable, usually it will be x, and will have an inequality symbol. Okay, so if we look at this first example, 4x plus 9 is less than 25. To solve this, we are going to treat it just like any other equation, only it does have that inequality symbol. We are trying to isolate the term that has the variable. We're going to isolate this 4x. So to isolate it, which means to get it by itself on one side of the inequality symbol or the other, we need to get rid of this 9. It's a positive 9, so we are going to subtract 9. And that will make it go away and leave us with just 4x. So if we subtract 9 from the left side of the inequality, we must also subtract 9 from the right side. And so we will be left with 4x is less than 16. Now we need to divide both sides by 4. 4 divided by 4 is 1, and that's what we're wanting is 1x is less than 4. If we are going to graph this on a number line, I'm looking for our number line. I'm looking for the number 4. I'm looking for an open dot, and I'm looking for your arrow to go to the left in the less than direction because the numbers to the left of 4 are less than 4. Okay, now this inequality that we have here, this second one, you need to pay close attention to this one. We have variables on both sides of the inequality symbol. So we need to take the 7x and put it with the 5x on the left side. So we're going to subtract 7x from the right side to make it go away. So we subtract 7x from the left side. 5x minus 7x is going to give us negative 2x. Now, we have our variables on the left. Now we need to take this constant of positive 2 and put it on the other side. So the inverse of adding 2 is subtracting 2. That makes it go away. So we have negative 2x is greater than negative 6. Okay, here comes the really important part right here, like important as in it's going to be on the quiz. When you have to divide or multiply through an inequality by a negative, the symbol must change. So right here we have negative 2x. Well, the inverse operation to multiply is to divide. And we need to divide this by negative 2. So we divide the other side by negative 2. Well, you know that when we multiply or divide by a negative, it changes the sign on everything. So you have a negative divided by negative is a positive. 2 divided by 2 is 1. It leaves you with x. But if it changed the sign here, this symbol must also change. Okay, it was greater than. Now it's going to less than. Huge, huge, huge. Very important. Look for that on the quiz. Okay. Negative by negative right here is a positive. 6 divided by 2 is 3. So again, looking for a number line. I'm looking for the number 3. I'm looking for an open dot because it does not have the equal to symbol with it. And I'm looking for your arrow to go to the left. Again, I would look at this. I would remember this for the quiz. When you multiply or divide through an inequality by a negative, the inequality symbol must change. This is a big hint. Quiz. In a compound inequality, we're going to have two inequality symbols, and they'll be joined together by an and or an or. An and is going to run all together like this. Negative 1 is less than 2x plus 7, which is less than 19. Whereas the or will literally have the word or written in it. Let's take a look at how these are going to graph out when we get finished with them. Okay, we are going to work from where the variable is. When we have two inequality symbols, we actually have three places that we look at. We have to the left of the first inequality symbol. We have in the middle of the two symbols. This would be the middle part. And then we also have to the right of that last inequality symbol. So we are going to work from the middle where our variable is. We have 2x plus 7. Okay, we need to isolate that 2x. It has a plus 7 with it. Now, to get rid of a positive 7, we subtract 7. If we subtract 7 in the middle, then we must subtract 7 on the right, and we must also subtract 7 on the left. Okay, so now you have negative 1 minus 7 is negative 8, which is less than 2x, which is less than 12. Okay, again, we are working from the term where our x is, which is in the middle. We have 2x. X is multiplied by 2, so we divide by 2. If we divide the middle by 2, we divide the left by 2 as well as the right by 2. Okay, so 2 divided by 2 is 1, and there's our x. Is less than 6, but is also greater than negative 4. So what are we looking for here on a number line? I'm looking for your endpoints, negative 4, and it's going to go all the way to positive 6. Again, both of these symbols are just less than. They do not have the equal to symbol with it. So we have an open dot on each of them. It's less than 6, but it's also greater than negative 4. Okay, now on to the OR statement. Okay, here is another compound inequality, and it's an OR. It literally will have the word OR in it. The AND will not. Okay, so we're just going to solve each of these inequalities separately. We have x plus 4 is less than or equal to 9. So to solve that, we subtract 4 from the left side, and we subtract 4 from the right side, and we get that x is less than or equal to 5. The second inequality is x plus 3 is greater than or equal to 7. So we will add 3 to the left side, so we add 3 to the right side. This goes away, and we have x is greater than or equal to 10. Okay, again, OR is in the middle, so it will be one way or the other. So on this number line, it's going to look a little bit different. Again, I'm going to look for your solutions, 5 and 10. Okay, the first one, x is less than or equal to 5. So I'm looking for you to put a dot on your 5, and you need to fill this one in. You fill this one in because it has the equal to symbol with it. And it's less than that, so it goes to the left. Okay, now it says, or x will be greater than or equal to 10. Again, I'm looking for the dot on 10. It has the equal to symbol here, so it will be filled in. And we're going to the right on that. Okay, I want you to compare these two graphs. If it says and, if your graph has and, it will all be together. It won't necessarily use the word. But I want you to look right here on the graph. The bar will come together right here. Whereas on an or, your graph will split apart. Okay, that's going to be another great quiz question. An or inequality graph is going to split and go opposite directions, and will connect. Okay, it kind of looks like a barbell, and connects and kind of looks like a barbell that you might lift weights with. Or splits apart and comes together.